In this last example, a bag will contain 3 marbles, yellow, green, and orange, and 2 marbles are to be selected at random without replacement from the bag. So for part A, we're going to determine the number of sample points in the sample space. So on this one, let's maybe draw our tree diagram first to help us see how many sample points there would be. So this is going to be a 2-stage experiment because we want to pull 2 marbles out of the bag. And on this one, we're going to have to keep track of the fact that we want to select the marbles without replacement, which means once we do our first pull, that marble will not go back in the bag. So for the first marble, what could we get? Well, we have options of yellow, green, and orange. So I'm going to draw 3 branches off of here. Oops. Yellow, green, and orange. So those are the options for the first marble. Now, whatever marble is pulled out first, that marble will not be replaced. So let's assume that we pull out a yellow marble first. Okay, so imagine the yellow marble was pulled from the bag, it was set to the side. Now, what marbles are left in the bag at that point? Just the green and orange ones, right? So I'm going to draw 2 branches here, and then I will have green and orange at the end of those branches. So notice at this point in time that the count got adjusted because I had to remove the marble that I pulled from that first step. If I pull a green marble first, on my second pull I could either get a yellow or an orange marble. And if I pull an orange marble first, on my second pull I could either get a yellow or a green. There are going to be 3 possible marbles that I could pull for that first stage. But since I'm doing this without replacement, when I go to that second stage, I will only have 2 marbles left in the bag. 3 times 2, using the counting principle, gives me 6 possibles in my sample space. So now let's answer a couple probability questions. So let's determine the probability of selecting exactly 1 green marble. So the probability of just getting 1 green. So out of the 6 outcomes, which ones have exactly 1 green? So you could either have yellow and then green. We could have pulled green and then yellow. Or it could be orange and then green. So there are 3 ways of getting exactly 1 green out of the 6 possibles, which simplifies to 1/2. Let's determine the probability of selecting at least 1 marble that is not orange. So at least 1 that is not orange. So there are 6 outcomes in my sample space. So let's kind of go through each of them. So in this first one, we have at least 1 of them not being orange. Now in this one we just have neither of them being orange, but at least 1 is not orange, so we would count it. In the second one, we have at least 1 of those marbles that is not orange. Specifically this guy right here, he would be yellow. Coming down here, this is at least 1 of them is not orange. This one, at least 1 of them is not orange, specifically this green guy. Coming down here, we have at least 1 not orange, because we have a yellow marble. And in this one, we have at least 1 that is not orange, because we have this green marble. So how many outcomes satisfy having at least 1 not orange? All 6 outcomes. So the probability you get at least 1 marble that's not orange, well, that's going to be a certain event. Okay, either you're only going to get 1 orange or you're going to get no oranges. But you're going to have at least 1 that won't be an orange marble. And this last one, let's determine the probability of selecting no yellow marbles. So out of these 6 possibilities, how many of them don't contain any yellow marbles? So this one contains yellow in the first pull, so I want to ignore these 2 outcomes. This one is green then yellow, so we won't include that. So we have green then orange. This one has a yellow, so we'll ignore that one, or we could have orange and then green. So there are 2 ways we can have no yellow marbles out of the 6 outcomes total, which would simplify to 1/3. So we're seeing in these examples that being able to sketch out a tree diagram is really helpful to be able to list the sample space in a very orderly manner. It helps us figure out our counting arguments, and sometimes it's helpful to actually be able to determine this counting argument before you start building your tree, just because you don't want to start getting into an example where the tree is going to be too big to draw out. But the tree is a nice visual representation to be able to refer to when you're figuring out probabilities for particular problems.